Ragu Bala is the CEO of NetObjects Inc., a company based in Southern California. He holds an MBA in finance from Wharton and an MS in computer science from RPI. Mr. Bala has significant domain expertise in the media industry, having led digital operations for over 100 brands, including Motor Trend, Hot Rod, Import Tuner, Automobile, Recoil, Shutterbug, and Slam. His responsibilities included managing digital assets across multiple mediums, including web, mobile, video, YouTube channels, and social media. The portfolio of digital assets he managed had a total visitor profile with monthly statistics of over 16 million unique visitors and 100 million page views. Mr. Bala also has deep expertise in search engine advertising and audience conversation from his stints at InfoSpace and Yahoo. Mr. Bala has been working on IoT since 2011 and has deep expertise in end-to-end IoT in multiple domains. His current focus areas are decentralized computing, distributed ledgers, IoT, and cryptocurrencies. So let us welcome Ragu Bala to the stage.
Can I get the click? Okay, so I'm going to talk about the convergence of IoT, AI, and blockchain. I'm the CEO of NetObjects, and we are a platform company. And I'm going to go through some theory, but a lot of practical examples of how to integrate these three technologies, which are quickly converging in the marketplace. So I'm going to start off with a few problems in the automation space, which is what we call ourselves. We're an intelligent automation platform. And I was recently speaking to the CIO of a major city, and since we do actually the automation of streetlights throughout Netherlands, I was asking him, what if we did the same thing for you? And his response was that whenever a streetlight breaks in the city, actually it's Phoenix, that citizens have to call in an 800 number to say that it's broken. So I said, that doesn't sound very automated at all, and obviously, there's room for improvement. And second example is on counterfeit products, and all of these are various examples. I'm going to show you real-life practical applications of how AI, IoT, and blockchain will solve them. So the second example is from The Guardian, where they say that about $509 billion worth of counterfeit products are currently being exported every year from China into the US. And so that's a huge counterfeit problem when it comes to big brands. So if you look at LVMH, which is Louis Vuitton, they are actually introducing a blockchain just to attack this particular problem. Last example is in the insurance industry, and I'm going to cover this in detail, which is insurance industry is changing rapidly, and there's a concept of parametric insurance, which is insurance which is a contract, but it's a live contract. Usually what happens in insurance, you write a policy and then it goes into effect, but there's no comparing of the data in the insurance with what's happening in the real world. So nowadays what they have is usage-based insurance, where your driving habits would dictate how much your premium is. So if you drive a lot, you pay more. You drive less, you pay less. You drive fast, you pay more. You drive normally, you pay less. Things of that nature. So there is a technology called robotic process automation, which is extremely hot right now, and a couple of players in that marketplace taking off. And NetObjects is the next iteration of robotic process automation. We call ourselves intelligent automation. So we are here to solve a few types of problems, and these include improving efficiency, reducing fraud, waste, enhancing safety, security, governance, compliance, and so on. And so the platform itself, if this is just a quick high-level diagram on the platform. So at the far left, usually we collect data, and the data could come in through sensors. That's where IoT side of it comes in. But it could also be regular files or other forms of data ingestion. And we also work with certain AI platforms like Basic AI and so on, where they do annotations of images and so on. I'll give you an example in the insurance industry later on, where accidents and so on, we're trying to replace the human adjuster with computer vision. So the data itself could come in through various sources. Once it gets into the platform, that's where our NetObjects logo is. There are 5 things that happen. First of all, we do analysis. We store the data, and then we do analysis, and this is where we integrate different types of AI engines. So I actually happen to teach both AI and blockchain for MIT Sloan Online currently as well. And so when we talk to AI engines, we are integrated currently with the Firefly, which does supervised learning. We're also in the midst of integrating with Veritone, which is another kind of AI tool set. And the AI system might come back with certain insights, and those insights can be actuated upon in real time. So let me give you an example. So for instance, let's say that we're instrumenting a traffic system, and there's a traffic jam. The traffic jam might be due to a breakdown of a car, maybe the traffic light broke down, or maybe there's an accident and so on. So the real-time response in this particular situation would be that you want, let's say, 3 traffic lights to turn 20 seconds longer red, those other 2 traffic lights to take 20 seconds longer green in order to dissipate the traffic. That might be the outcome. So how do you deal with that? And many systems that we have currently are not real-time. Everything that we do here is real-time. That means it happens immediately. You don't need to go and code and have a release of software in order to do that. This has to happen immediately because cars are stuck on the road. So you have this remote actuation that happens that you see on the diagram over there. We also have to talk to enterprise systems. Like coming back to my Phoenix example, their street lights and traffic lights are all in Microsoft Dynamics. So they have static data that's in a database, but then they don't have up-to-the-minute data on the particular street light or a traffic light, what's happening right now, whether it's working, not working, things like that, they don't know. So we have integration with existing platforms. Hold on, there's one more. So and then finally there are humans in the process, which is this messaging. We have to do SMS, email, mobile push. And then the final part is blockchain. I'm going to cover it in detail, but we talked to different types of blockchain. We have introduced something called DQL, which is distributed ledger query language. For those who know database, SQL, this is a variation of SQL. So we talked to different ledgers, IOTA, Stellar, Ethereum, Hyperledger, NEM, Hashgraph, Helix, and so on. So here comes the idea of parametric contracts. So in parametric contracts, what happens is, if you take a legal contract, I was a CTO for many years, and a lot of times I would sign service level agreements, and then once I sign the service level agreement, I put in my drawer and don't look at it until the next year when I have to renew the contract. So these contracts are sort of like dead, they're not live. So here with blockchain, what we do is we do live contracts. The same idea could be used for property management. So we're working with Colliers to do property management contracts, where they have leases, they have a lot of different types of contracts, and these contracts can come alive. You basically extract all of the variables in the contract, and those variables could be compared with live input, which can come in through IoT and other means. And you can say, okay, you know what, the contract says 99% uptime is below 99%, so what are the remedies? The remedies might be kick off a smart contract to do a payment of a penalty that the vendor has to pay because the service level was below what was agreed upon. So things of that nature. So this sort of live contract using blockchain is becoming very useful, but blockchain by itself is not the whole thing. We need input coming in from IoT and so on. Okay, so the next few slides, I'm just going to go over a little bit of theory. I'm not going to dwell on it, and then I'm going to go into some practical examples. So distributed ledgers themselves, if you compare those, that's on the right side. On the left side is your regular centralized ledger. So when you talk about centralized ledger, okay, let's take a service like, let's say Facebook or Google and so on. They have a centralized system. They control all of the data. And that's one of the issues where, if you had that Cambridge Analytics example from earlier this year, where people get worried when big companies collect so much data, they are the center of the universe, and all of your data is with them, it's not in your hands. Same thing happening in the medical industry. Cerner, Epic, people like that, they hold all your data. They don't want to share it. Government had to pass a law in order to make your data be your own. So in the world of distributed ledger, the idea is the data is distributed among multiple nodes. And those nodes are the 4 sort of buildings over there, and all of them share data. So I would like to also clarify that blockchain is just one implementation of distributed ledgers. There are others, some called directed acyclic graphs. But in the case of blockchain itself, basically for those in computer science, this is very common. The top part looks like a linked list, and then the bottom part looks like a tree structure. So the tree structure is called a Merkle root. The top part is a linked list. So it's like a chain of train cars hitched to one another. And that's how blockchain structure looks under the hood. So in blockchain, what happens is you have multiple nodes which have to agree upon some decision that is being made. Currently, one of our customers that we are working with, and we've got customers in 4 continents who license our platform. But one of the customers, I'll use as an example, is in the diamond industry. So diamond industry is about 25 companies that control the entire industry. A lot of them are in India, actually, who do cutting and polishing and so on. And so what we're working in the diamond industry, we are creating our own blockchain. And that blockchain is a consortium approach. So in blockchain, a lot of times it's consortiums. So you have public blockchains and you have permission blockchains, which are like consortiums, which are only certain people can join the blockchain. Public blockchain is like for payments and so on, Ethereum, Ethereum, Bitcoin, and so on. So now in a blockchain structure, what happens is all the nodes have to agree upon some decision, and before it is ratified, it has to be ratified, voted upon, and then the transaction gets approved. So since all the nodes are not owned by a single entity, so they have to, all the other nodes have to all agree, then only it goes through. So that's the kind of flow that I'm showing over here. Next. So a lot of people come to us and say, you know what, I want to use blockchain for this or that, and so there's a decision tree as to one has to take, to determine whether blockchain is appropriate for your particular problem. And I don't want to go through all of this, but in several cases, it may not, you don't need a blockchain. Some people are trying to force fit a technology just because it's hot, but blockchain is useful whenever you have trust issues. So for example, in supply chain, you might have different players, buyer, seller, buyer's bank, seller's bank, logistics company, trucking company, things like that. In that case, there's a lot of trust issues because of chain of custody. So that would be an example where blockchain makes sense. But in some industries where all the players are trusting each other or they are within a single enterprise, it doesn't really make sense. You can use regular database technology. Then you also have an option of whether it's going to be a public blockchain or a private blockchain. Next. So here's an important diagram. A lot of you might know databases and have used things like SQL Server, Oracle, things of that nature. The picture on the on the left side is like a traditional database where all the nodes belong to a single enterprise. Whereas the picture on the right side is when all the nodes belong to different members of the consortium. So they all have to agree upon some decision, which is why you have that kind of a bifurcation, and that's the trust boundary, we call it. So when all the nodes have to trust one another, that's when you need blockchain. So this is maybe a little bit hard to see over here, but there are 4 types of blockchain. One is called Fed. You have to do retinal scan, and you take the retinal scan. If you go to the next slide, you'll see you take the retinal scan first, you put it into the system, and then next time the person shows up at a particular service facility, you know that this person showed up here. And if someone doesn't show up for a while, that means something really happened to them, and the social people can take care of these homeless folks and so on. I think just a couple more examples. This one is in the InsurTech space for cars again, for scratches, dings, dents. You can keep track of any vehicle's entire history. So Carfax reports and so on, they give you some of the history, but they don't necessarily give you all of it. And so, so this one is a more, I'd say, more comprehensive way of tracking all of the problems with cars. So the app itself looks somewhat like this. Keep going. And then I think this is the last one where it's for IT assets. So this particular company does work with people like, big corporations. But one example here I'm going to show you is with JPL in Pasadena, Jet Propulsion Laboratory. So all the if you go next slide, please. So you'll see small bubbles on the map. So there's a kind of a flow map, and we know where the UPS systems are, and whenever any UPS system is below a threshold of power, let's say it's below 50% of battery life or things like that, you can easily see that on the screen and get live data. So everything is real time, like I mentioned earlier. So there are three more quick initiatives that I'll just mention, like oil and gas, big one. So here what happens is there's also an ecosystem. So in the oil and gas industry, what happens is there might be a big company like Chevron or Phillips, which owns oil field, but then they outsource the work to like consulting companies who go and drill the oil and so on. But sometimes the people who are drilling might say, okay, you know what, I took 10,000 barrels of oil out of the ground. When in fact they took 12 and then 2 went missing. So how do you know that for a fact? So you need IoT. So we're working with a company called OmniFlow, which is a flow meter. And the flow meter gives us the actual real-time data that we store in blockchain so that the owner of the oil field and everyone else in the ecosystem can see the same data at the same time. Nothing can go just mysteriously missing. Happens a lot, apparently. So next one is, keep going back. Second one is field service maintenance. This is an interesting problem. We're working with a major elevator company. So an elevator repairman, and this applies to any other field service industry actually. Repairman goes into the elevator, starts fixing it, but then he sees a part and he doesn't know how to fix it. All they have to do is use your phone, do optical character recognition on the label, and then the part will go and look up you'll go and figure out the part number from a lot of data on that label. And then pick out the correct technical documentation so the guy can fix the stuff. If the stuff is not around, he can even reorder the part from the phone itself. So it's really good for any sort of field service maintenance. Another one is insurance, a major car insurance company. Sometimes they advertise on TV, I don't mention who. But so what we are doing for them is getting rid of the insurance adjuster. So you just train the picture on the damage to the vehicle using computer vision, and it does some machine learning to figure out, okay, you know what, this claim should be 3,000 or this claim should be 5,000 because of the extent of the damage. So, like previous speakers spoke, we cannot completely replace a human, but let's say that they have 20 insurance adjusters today, we can cut it down to 2. And then the other 18 could be just computer vision doing the work. So, yeah. So that's basically it. Any questions that I can help answer?
Any questions? Any questions?
So are your solutions tailored to each domain, or it's like one solution across that works across all domains?
So we are a platform. So we have one of the slides showed like a platform that collects data through, we call it payloads of data. It goes through our engine, and our engine does storage, analysis, actuation, messaging, and blockchain integration. So we are the platform, and all of the examples that I showed are companies who have licensed our platform, who then build on top of it apps and so on. Sometimes we help them build, sometimes they build it on their own, but the platform is the same under the hood.
Any more? Yes.
So, thank you. I am interested in the academic credentialing, that slide, and the technology that you're developing for that. I'm involved in something called the Badging Alliance. For example, those who are here today attended all the sessions, and they learned a lot of new information and gathered knowledge. And it's worthy of putting that in their resume. And today, say, Balaji can provide a micro-credential that, as part of their lifelong learning, they have that. So does your...
So we can track like CEUs, which are like continuing education credits and so on. So it's not only limited to academic things, like what you say, it could be like other forms of learning, or it could be for other technical certification, like, I'm a plumber and I went for training, or I'm an accountant, I have to take certain credits every year to keep my credentials for CPA and things like that. So it could be those types of things as well. So yeah, absolutely, yes.
So it is a universal platform, so it can apply to a K-12 student or a college student, or a professional environment.
Ad
like
hoc,
this.
yeah. So actually it's kind of important because, we might not take it very seriously, but, we all, I'll give you two extreme examples. One is kind of funny, but so let's say that, people in Syria, right? The university you went to, maybe no longer there, just got bombed out. So if you are now a refugee, you moved from Syria to some neighboring country, you can't even prove that you're a lawyer or a doctor or something like that because there's no one to go and prove. Your degree is vanished, technically speaking, school is not there. That's the extreme example. But the other example is like, Trump University also went out of business. So, like a lot of private schools also disappeared in America. So those people are also stuck. Where do you go and figure out whether your credential is real or not? You don't know. So there are a lot of, those types of things going on as well. So for all that, why I wanted to say blockchain is very good, because even if the school disappeared, your data is still in the other nodes, and you can still verify whether you went to school there or not. That's why it's useful to have a consortium.
Thank you.
So in each of the domains, we partner with subject matter expertise. But the platform is the same. Actually, they all, if you look at it, at the end of the day, I look at it very abstractly. And there are three things: collect data, analyze it, store it, and share it, right? So that's the three basic things. And then what we call track, trace, and monitor. So under the hood, the platform is actually very, very reusable. We've got about 10 or 12 building blocks, which you can sort of like, I say all of Italian food looks the same. It's always cheese, some pasta, and some sauce. So you just mix it up, you get ziti, mix it up, you get lasagna, you just mix it up, you get spaghetti, whatever. So it's all the same ingredients, just repackaged in different, almost every culture food, tends to be like that. Well, I'll say there are a few basic things. No, I'm not saying. Within Punjabi itself, it will be like similar. Within South Indian, it will be similar. Base will be the same.
Yeah, the idea of the blockchain is that because it's in a distributed system, it's very hard to hack or change, right?
Right.
But bitcoins and things like that are based on blockchain, but we hear that there have been hacks of Bitcoin and people are, so how is that happening?
So usually I think there are inside jobs where people track, give away your wallet ID and things like that. So I think that's mainly, but from a cryptographical sense, it uses cryptography that's supposed to be, it takes 40 years to break it. Until you get quantum computing, it's very hard to break the encryption, actually, technically speaking. So these hacks are usually inside jobs of people who know someone else's, like getting a password and then going in and taking the money and moving it from your account to someone else's account, things like that. So that's usually the case. I don't think it's the probability is like what we use is something called SHA-256 currently, which is a standard for the encryption, and it's very hard to break. I mean, I just don't see it being a technical break. It's some other hack. There's different types of hacks in blockchain. Like there's something called 51% attack. So if you get hold of more than 51% of the nodes, It's not happened in blockchain, but some of the smaller coins and so on, people have done that. Then that's a problem. But again, if you are doing like permission blockchain and you have a trusted group of 10 companies working together, I don't think those companies behave in that manner to take over each other's nodes and so on. So there shouldn't be a problem. For a lot, yeah, go ahead.
In these private chains, right, there wouldn't be enough nodes. I know it's private and it's trusted people, but there wouldn't be enough nodes like a public
Chain, yes. Public chain, the problem people are worried about is, let's say, China controls a lot of the Bitcoin nodes right now. And so if like one country or one organization begins to control more than N% of the nodes, then they have a chance of, it's no longer democratic. They'll have more voting power, and that's the problem. So that's what people are talking about as far as 51% attack. But there are many types of attacks. But
it could happen to the private chains too, right? If someone hacks into a system.
Yeah, I mean, private chain, usually the access is limited, so the chances are not. It's like an intranet versus internet. So.
Thank you.
Any more questions? Well,
All right. Thank you.
thank you. Well, thank you, Ragu.